Good afternoon, everyone. My name is Sahai Sheila. I'm from Shriram Engineering College. Today, we are diving deep into the foundation of our planet through the lens of engineering geology. Let's begin by understanding geology is a Greek word meaning earth studies. It covers everything from Earth's creation to the present day. Also, the vital branch is physical geology, which focuses on Earth origin and its internal structure. So why does it matter to an engineer to know the internal structure? Because it directly affects the stability, safety, and economy of the structure we build, such as bridges, tunnels, and towers. So let's begin our topic. Internal structure is not exposed to human, but through geophysical data, it can be understood as 6,371 kilometer will be the interior earth thickness, and it is generally divided into crust, mantle, and core. As you know, the crust is divided into oceanic layer and continental layer. Oceanic layer thickness will be 5 to 6 kilometers, and continental will be 35 to 70 kilometers. At the oceanic layer thickness, there will be a basaltic rock, and it is a thin type of crust. Generally, the continental crust have the denser rocks, that is sedimentary, igneous, and metamorphic rocks. And last will be the mountain region, that 60 to 70 kilometers will be there. The crust is again divided into upper crust and the lower crust. The upper crust is rich in silica and alumina. Lower crust is divided into silica and magnesium. So there is a discontinuity, that is the lower crust and upper mantle. Between there will be a discontinuity, and this discontinuity will lead the magnitude, decreases the magnitude when it reaches the upper mantle. So that is called Mohorovic discontinuity or MOHO. It is a significant boundary layer deep within Earth that separates the crust from upper mantle, and it is discovered by Andrzej Mohorovic in 1909. This is the first seismic discontinuity on the Earth. So to know about the discontinuity clearly, we have to know seismic waves. These are generally three types: primary, secondary, and L waves. L waves are love waves confined only to surface, whereas its primary and secondary will move towards the depth. While in crust it will be 5.5 km per second, and after crossing this Mohorovic discontinuity, the P wave attains 7.4 km per second, and S wave from 3.3 km per second to it will attain 4.4 km per second. This drastic increase in speed is generally because of different types of material presence. So after Gutenberg discontinuity, P wave will increases. This is also because of different kind of materials. So this Gutenberg discontinuity will be found in mantle. So first of all, what is a mantle? Mantle is a layer which lies between crust and core. The upper boundary will be the Mohorovic discontinuity, and the lower boundary will be the Gutenberg discontinuity. The thickness will be 2,900 kilometers up to. The upper mantle is 35 to 1000 kilometer, and the lower mantle will be 1000 kilometer to 2000 kilometer. Mantle generally contains only magnesium, iron, silica, rocks like ductite. All three rocks rich in magnesium, iron, and silica, and all the pyroxene, olivine, ultra basic igneous rocks that will be appeared in a green color, green mineral. It is a the ion content is enhanced because we know magnesium, iron, and silica. The previous slide I have been told. So the uppermost mantle is semi-solid. Therefore, there will be a velocity of wave will be decreased. So this zone is called lower velocity zone because the mantle extends from 35 kilometers. That is, the lower crest ends with 35 kilometers. From the 35 kilometer to 1000 kilometer, then it is also called as asthenosphere. And the lower upper mantle will be solid. The upper will be semi-solid and the lower will be solid. The upper portion is not solid, but it is in the plasticky state. The velocity is lower. The asthenosphere, primarily the upper mantle is called asthenosphere. That means it is strength. The density of the material in a crust is 2.8 gram per centimeter and the mantle is 3.2 gram per centimeter. This shows that there is a presence of some materials like magnesium, pyroxenes like that. The mantle and core separation is Gutenberg discontinuity. As I said, Mohorovic discontinuity is between the crust and the mantle. Same way here is Gutenberg and discontinuity. The density will be 5.7 gram per centimeter. This was invented by Gutenberg in 1918. The velocity of the primary wave, that is P wave, at the lower mantle will attain 13.6 km per second. Previously it was 7.4. Now the uppermost core, the velocity will be 8.1 km per second. Also, there is a different kind of material that is present between the mantle and the upper core. The secondary wave, it will not able to travel because the core will be in generally liquid state. That's why it won't be able to travel. So the primary wave will travel across solid, liquid and gaseous layer. So what is core? It is the inner layer of the earth. Again, through the discussion of geophysical data, we can just say it has outer core and inner core. It has a layer of 2,900 kilometers to 5,150 kilometers. The density will be 9.9 gram per centimeter and it was invented in the year 1936. Ingu Legman. He is a Danish seismologist. So the density of the core enhanced within depth and it has iron and nickel. The secondary wave will disappear because it won't be able to travel through the liquid because the outer core is filled of liquid and the inner core is generally filled with gases. Thank you.